Hello and welcome to Tensar Ground Coffee, a few minutes on ground engineering to enjoy while having your coffee. What an exciting episode this time. We're near Krakow in Poland on the site of the construction of the new northern bypass to the city. Now what we're doing is we're verifying the new parameters for the t-value method for working platforms with the new Tensar Interax GeoGrid. It's very important to do this sort of full-scale validation. There are always uncertainties in ground engineering. No matter how careful we are with the derivation of the calculations, we must always go out and do full-scale validation. So let's just wander over here, Brian. First of all, there's the new Tensar Interax GeoGrid that we've installed in here into this little trial platform. If I go down into this trench here, we can get a little look at the subgrade that's down here. So where it hasn't dried out, we've got a cohesive subgrade. It's feels like a silt and clay, but I can press my thumb into there, so it's probably a firm subgrade. We've done the testing on it, so we'll get the proper parameters for the strength, but it's certainly suitable for this sort of test, the sort of conditions where you would need a working platform for piling plum. Now, to verify this, we need a large plate load test. We'll have a closer look at that in a minute, but what you see around you is all the reaction frame that's needed in order to apply the load. So in order to push a plate down, you need to react against something. So we've got CMC columns installed on the four corners of the reaction frame, so they're acting in tension. But just to give you an idea of how strong the mechanically stabilized layer is, we were not able to fail the plate, and we needed to add this extra weight from these concrete slabs on the top in order to get enough reaction to fail the plate. So let's have a closer look at the plate, Brian. Let's go under here. Mind your head. So here you can see the circular plate, a 1 meter circular plate. So it needs to be that big to match typical track widths on piling plant. It's no good using a smaller plate because you're not going to get the depth of influence. It's the width that really matters. So although a piling rig has long tracks, it's the width of the track that really dictates the depth of influence. So that's why we've gone for a 1 meter circular plate. And this started at the surface, so the test is finished now, and you see how far we had to push it down in order to get bearing capacity failure, and we can see some heave around the edges as well. So it's no good just doing these tests to working load. We're verifying an ultimate limit state design here, so we need to be 100% sure that we've got the safety margins that we need in the design. So that's all for this episode. Thanks for watching, and see you next time.